Welcome back. Today we're going to be talking about rational numbers and application. Our content objective is students will be able to find the product and quotient of rational numbers within real-world context. Language objective is students will be able to reason verbally why a situation leads to either multiplication or division. And why am I learning this? Well, it's important for many real-life problems like finding the total change in weight. So remember from the previous lesson, what we did before calculating is we estimated. So for example, -9 times -8 1/4, we said -9 is -9 and -8 1/4 is approximately -8. And so we found the product of -9 and -8, which gave us approximately 72. Okay, we did this, and then after estimating, we actually did the math. We said -9 of 8 1/4. Well, that's going to be 9 times -33/4. -9, and then we would multiply straight across, simplify it, and our answer was 74 1/4. So it's within reason. This does sound reasonable. Now, if my answer was 7 1/4, then I should probably be concerned because those answers are nowhere near each other. So that's the nice thing about estimating, is we're checking to see if our answers actually make sense, and we're not just putting in numbers and submitting it as an answer when it doesn't. Number 1, Dory can run 3.25 miles every hour. How long will it take her to run a race that's 16 1/4 miles long? Well, let's see. First, we're either asked to write an equation or draw a model. Well, I'm going to go ahead and create a table to kind of organize my thoughts. Well, if Dory can run 3.25 miles every hour, in 1 hour, I expect her to go 3.25 miles. In 2 hours, I expect that to double to 6.5 miles. In 3 hours, I expect that to triple to 9.75 miles. So notice here for 4 hours, I expect her to make it to 13 miles, and then 5 hours is what would take her to 16 1/4. So now obviously you don't want to keep doing this every single time because that can be very time consuming. So what would have been a quicker way of determining that? Well, hopefully your answer is you could have divided. You could have taken 6 1/4 and divided it by 3 25 Now real quick before we move on, let's estimate that answer. So I'm going to go ahead and estimate and say 16 1/4 is pretty close to 16, and 3 25 is pretty close to 3. So if I take 16 and divide it by 3, that will leave me with my 5 1/3. So if you're wondering, that's how I got my 5 1/3. So that's just a good estimation. My answer should be around 5 1/3 hours. So let me actually do the exact math and see what my answer is. So I'm going to go ahead and take 16 1/4 divided by 3 25 The preferred method when you have both a fraction and decimal is to turn things into fractions. And it's going to make a lot more sense when you go to 8th grade. And the main reason why we do choose fractions over decimals is because fractions allow the numbers to stay exact. With decimals, there are times where things don't divide in evenly and you end up having to work with a repeating decimal or something like that. So fractions is definitely preferred. So before I do the math, I'm going to go ahead and convert these into an improper fraction. 4 times 16 is 64, plus 1 is 65. So we have 65 over 4 divided by, another way I can read this is 3 1/4, which looks something like this, 3 1/4. 4 times 3 is 12, plus 1 is 13. So this is what it looks like. Now, I do understand that dividing by 13/4 is equivalent to multiplying that by the reciprocal, so it's the same as multiplying by 4 over 13. So I'm going to go ahead and take 65/4 and multiply that by 4/13. Now, the 4s are going to cross cancel, leaving us with 65 over 13, which is going to reduce to just 5. So to answer the question, how long will Dory take to run a race that's 16 1/4 miles long? Well, it would take 5 hours. So please make sure you're using the correct unit. Some students don't read into the small details of the problems, so be very careful. Number 2, from 6 p.m. to 6 a.m., the temperature dropped 1.4 degrees each hour. What was the total change in temperature between 6 p.m. and 6 a.m.? Well, just like before, we're expected to either write an equation or draw a model. Now, real quick, what's going to help me is if I write it out as a table to kind of track what the temperature is at a given time. So for example, if it's dropping 1.4 degrees each hour, okay, I would expect by the first hour, okay, which means I'm going from 6 p.m. to 7, it's dropping down 1.4 degrees. Now in the second hour, aka here, this is going to be by 7 p.m., this is going to be by 8 p.m. That's going to drop another 1.4, which leads me to negative 2.4. Next hour, which would lead me to 6 p.m., okay, is going to drop down to, let's see, another 1.4, which leaves us with negative 4.2. So notice I can definitely continue this, but now it's going to take me a lot more time. So what would be quicker? Well, it would be quicker to first understand to go from 6 p.m. to 6 a.m. That is a 12-hour difference. Okay, so if every single hour it's dropping 1.4 degrees, what is a quicker way? Well, I would write the equation. I would take 12 and multiply that by negative 1.4, because again, every single hour it's dropping 1.4 degrees. So to make things a lot quicker, we'd simply multiply 12 by negative 1.4. So before we actually do the math, let's go ahead and just estimate. 12 is obviously 12, but negative 1.4 could be estimated to about negative 1. So it should be around negative 12. So now let's actually do the math. If I take 12 and multiply it by negative 1.4, you should get 16.8. And just a quick reminder, if you need the recap of how to multiply, I would multiply 4 times 2, which is 8, 4 times 1, which is 4, 2 times 1, which is 2, 1 times 1, which is 1. And then I'm just going to move my decimal total of ones, place a decimal value, and I do end up with a 16.8. Well, you'll notice that technically the answer is a negative 16.8, but you don't see a negative in my response. Well, it's because I use the word dropped. Dropped kind of is indicating the negative aspect of it. So I can say the temperature dropped 16.8 degrees. Number 3. At this point, what I would like you to do is pause the video and try number 3 by yourself. So for number 13, it says Bridget wants to make 14 matching hair bows for her friends. Each bow requires 3/4 of a yard of ribbon. How many yards of ribbon will Bridget need to make all these hair bows? Well, first, write an equation or draw a model. Well, first of all, I hope you understand that to make one bow, it's going to take 3/4 of a yard, right? So for 1, it will take 3/4. For 2, it's going to take twice as much of the material, so it's going to be 1.5. For 3, it's going to take 3 times as many material, which is going to be 2 1/4. So how much would it take to have 14 of them? Well, it's going to take 14 times as much. So a quicker way would have been to multiply 14 by 3/4. Now quickly estimating that, 14 is estimated to just be 14. 3/4 could be estimated to be around 1. So you expect the answer to be around 14. Now to actually do the math, I'm going to go ahead and multiply straight across and do 14 over 1 times 3 over 4. Notice I can cross reduce between 14 and 4 by a factor of 2. 14 divided by 2 is 7. 4 divided by 2 is 2, leaving me with 21 over 2. Now, this is 21 halves. If you have 21 halves, altogether you basically have 10.5. Okay, so Bridget needs 10.5 yards of ribbon to make these 14 bows for her friends. Number 4, guess what? I'd like you to do the same. I'd like you to pause the video and try this one by yourself. Number 4 says there are 18 apple trees in my orchard. If I can harvest the fruit from 1 2/3 trees each day, how many days will it take to harvest the entire orchard? First, let's go ahead and create some sort of model, okay? I know this sounds silly, but it would be nice if you can kind of imagine, I'm just going to draw a very silly apple tree. This is going to be my apple tree that looks like a lollipop. Okay, pretend this is an apple tree. I'm going to go ahead and draw 18 of them. So here's 5. So this would mean there's 10 here. I know they're looking worse as we go along. There is 15 here, 16, 17, 18. So real quick, I am imagining that every single day I'm able to harvest 1 2/3. So just to kind of visualize here, let's do a different color. Let's do this color. In one day, I can do 1 and just 2/3 of it, maybe like that. Okay. In the second day, I can do the same. I can do 1 and 2/3. Here's a 1/3 left from the other day, so I'm just going to take 1/3 from this day. Now, continuing on, I can go ahead and take, for the next day, I can do 1, and this is a perfect 2/3 left. So I'm going to keep going until I finally do all 18 trees. Now, do you really want to realistically do this until they're all done? Absolutely not. You're essentially trying to figure out how many 1 2/3 it's going to take to get to 18. So what's a quicker way of doing that? Hopefully your answer is just to divide, right? So I would go ahead and say that the model is going to be 18 divided by 1 2/3. Now, real quick before we actually do the math, let's estimate, okay? 18 is, of course, 18, and 1 2/3 is pretty darn close to 2. So to estimate, I'm going to say 18 divided by 2 is going to be 9. So my approximation is going to be around 9. Now, is it going to be exactly 9, or is it going to necessarily start with a 9? No, but it's a good approximation. So from here, let's actually figure out what the answer is. We have 18, and we're going to divide by 1 2/3. So we're going to turn this into an improper fraction. 3 times 1 is 3, plus 2 is going to be 5. So we have 5/3. I'm going to go ahead and turn this into a fraction like so. Now, I do understand dividing by 5/3 is the same as multiplying by 3/5, which is the reciprocal of it. So we're going to go ahead and take that 18 and multiply by 3/5. I'm going to check if I can cross reduce. Unfortunately, I can't. I'm going to multiply straight across 18 times 3. That's going to give me a total of 54 fifths. If you have 54 fifths, what does that give you? Well, it's going to go in 10 times with the remainder of 4. So that's going to be 10 4/5. Now, let's answer the actual question. It says, how many days will it take to harvest the entire orchard? Well, I would say it would take 10 4/5 of a day. Now, someone can argue and say, really, Miss Saying, you're going to say 10 4/5 of a day? You might want to just round that up and say, well, it's going to take approximately 11 days, okay? But if they're looking for an exact answer, you would say 10 4/5 of a day. So just keep that in mind. Number 5, it says, I want to use a recipe for muffins that calls for 3 cups of flour and 2 eggs. If I only have 1 egg, how much flour should I use? Well, notice the recipe calls for 2 eggs, but we only have 1, which means we only have half of what we need. So guess what? If we only have half of the eggs, I'm only going to need half of the flour, right? So what I'm going to do is just take half of the cups of flour that I would originally need, which is 3. So let's just go ahead and figure out what is half of 3. Some of you can do that mentally and say, well, half of 3 is just 1.5. Now, if you can't do that in your head, simply multiply 1/2 times 3/1, and you would get 3/2, which will turn into 1.5. So to the answer to the question, how much flour would you need if you only have 1 egg? I would say I will need 1.5 cups of flour. And this is actually a very useful thing to know how to do, because that often happens with recipes. Maybe this recipe will give you a certain amount. Maybe it's too much food and you want to decrease it so that's not as much ingredients. So you might want to alter it that way. Or possibly, like in this situation, you don't have that much ingredient, so you can only possibly do half of it or 1/4 of it, etc. So real quick, we've done problems like this before where we're given both fractions and decimals. And in the past, we've solved it both ways, one doing the converting everything to fractions and one converting everything into decimals. You know my side of the story. I do definitely prefer you to turn things into fractions, mainly because in 8th grade, when we're solving equations involving fractions and decimals, fraction is a better bet because it keeps your answers exact. Turning everything into decimal could be a tricky situation sometimes because it can lead to repeating decimals and things like that. So you're going to find yourself having to estimate as you work on by, when it might be just a better deal to keep things as fractions because they remain exact. So for number 6, we have negative 5/10 times 5/3. Quickly, let's go ahead and estimate. I'm going to say the negative half is negative half, and I'm going to estimate 5/3 to be around 2. So if I multiply that, that should be around a negative 1. Okay, so notice this is missing a negative. Let's put that there. There you go. Okay, so here I would first turn everything into a decimal. I would say, okay, this is negative 1/2. So I'll write negative 1/2 times 5/3. Now here, I'm going to check if I can cross reduce, which I can't. And right away, before I forget, a negative times a positive is a negative. Don't want to lose sight of that. I'm just going to multiply straight across, and I'm going to get 5/6. Is a negative 5/6 pretty close to negative 1? The answer is yes, so that's a good sign. Now, was there another way to have approach this problem? Absolutely, you could have turned both into decimals. I could have kept this as a negative, real quick, I could have kept that as a negative 5/10, and if I divided 5 by 3, I would have gotten a 1.6 repeating on the 6. Now here's a prime example now. Do we really want to be multiplying a repeating decimal with another decimal? The answer is no. Okay, so again, it's going to be a really good idea to just go ahead and stick with fractions, and you're going to find your life so much better when you go to 8th grade because you're going to be practicing so much with fractions that you're going to feel so comfortable and more confident in your fraction. So I know fraction isn't always a student's first choice. A lot of students like to go to decimals, but trust me, it's going to be less work in the long run, especially when you get to 8th grade. Okay, number 7. First, we're going to estimate, and then we're going to go ahead and start dividing. So a negative 2/5, I'm going to say that's approximately half because 2 out of 5, that is approximately half. And I'm going to say the negative 86/100 is approximately negative 1. So if I take a negative 1/2 and I divide that by a negative 1, that's going to be approximately a 1. It's going to be approximately 1/2. So keeping that in mind, what I'm going to do first is decide, okay, a negative divided by negative is a positive. Now I'm actually going to put a positive in my answer, for example, on my homework. No, but it kind of tells me that I did take care of the sign already. Okay, so hopefully at this point I've convinced you it might be a better idea to just go ahead and convert things into fractions. So this is already a fraction, so I'm going to leave it as negative 2/5 divided by, now here, be very careful, this is a negative 86/100. Now actually, I'm going to go back and go ahead and take away the negative. Why? Because I already took care of the sign, so I don't have to worry about it anymore. So back to here, this I would read this as 86/100. Now what's wrong with this? It's not reduced, and would I highly suggest that you reduce it? Absolutely. I noticed both of these are even, so I could divide them. So let's go ahead and divide 86 over 100 by a 2. That's going to give me 43 over 50. Now that makes things a little bit better. So let me rewrite this real quick as 2/5 divided by 43/50. Now at this point, I'm going to go ahead and understand that dividing by 43/50 is essentially the same as multiplying by the reciprocal of it, which is going to be 50/43. And this is a 0, not a 6. Okay, so I'm going to go ahead and take the 2/5 and multiply by 50 over 43. I'm going to check if I can cross reduce, which I can. 50 and 5 have a factor of 5 in common. So 5 divided by 5 is 1. 50 divided by 5 becomes a 10. So I'm left with 20 over 43. Now, I already determined it's going to be positive, so I'm just going to go ahead and tack on that it's 20 over 43. Now, for this one, would it be possible to go ahead and just divide and turn this into a decimal? The answer is absolutely. Now, if you actually do the math, so let me show you real quick what that's going to look like. And so this, I would have to turn 2/5 into a decimal. 2 divided by 5. This goes in 4/10 times. So we have a 4/10 divided by a 8600ths. Notice I'm leaving off the signs because, again, I already took care of it. I'm going to do some side work. I'm going to say 4/10 divided by 8600ths. I move my decimal over 2 places. And I'm going to start dividing. Notice here, it's not the easiest when you're dividing by a number greater than 12 because we typically don't know multiples greater than 12 off the top of our head. So that is a little bit of work. Now with fractions, did you find that it would to be a little bit quicker? The answer is going to be yes. And the more that you practice, the more it's going to be second nature to you. So that's the idea, is to get you very comfortable with fractions. But would you still get the same answer? Yes, but you would get it in decimal form. But still, I highly suggest you stick with fractions. Here, in fact, if you did divide, this is what you would end up with. It's all of these numbers repeated, and you wouldn't recognize that this whole chain is repeated until you've done a lot. So, what's better? Hopefully you realize with this that fractions is probably your better choice. You're not going to have to deal with these repeated decimals. Okay, number 8. Find each product or quotient. So again, hopefully you're convinced that the best thing to do is to turn everything into fractions. Okay, so here, this is already a fraction, so I'm going to keep it as that. This is a half, so I'm going to go ahead and multiply by half. Here, it's already a fraction, so I'm going to keep it like so. And this is basically a negative 1 1/4, so I'm going to go ahead and write it as negative 1 1/4. Okay, right away I'm going to decide that positive times positive is positive. A negative times negative is positive, so positive times positive is a positive. Took care of that. Not going to worry about whether or not my sign is right. Now I am going to turn this into a improper fraction, so I'm going to go ahead and keep this the same. 4th 1/2. Notice I'm going to make this 2/3 because I already took care of the sign. And I'm going to go ahead and turn this into a improper fraction, which would be 5/4. Now I'm going to check if I can cross reduce with any of these fractions. I notice these two fractions have a 2 in common, so I'm going to cross reduce that to a 1. Now, are there any other factors I can reduce? The answer is no. So that's going to leave me with 1 times 1 times 1 times 5, which is just 5. Then I have 4 times 1 times 3 times 4. So 3 times 4 is your 12. 12 times 4 is 48. So my answer is 5 over 48. So that is our answer. So here it's the product of all 4 of these fractions or decimals is 5 over 48. Well, guess what? That actually concludes the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.